say, math learners? Come on, let's learn something new. You're not alone. Let's do it together.
As for today's video, we'll be tackling about coefficient of determination and standard error of the estimate. In this topic, we'll be talking about a percentage of our predictions to be true or to be false. In other words, we are here to prove our hypothesis.
Now, let us talk about the type of variation for the regression model. Example: consider the following hypothetical regression model. We have our x values 1, 2, 3, 4, and 5, and our y values, which is 10, 8, 12, 16, and 20. The procedure for finding the three types of variation is as follows. So our step 1 is to find the predicted y values. For us to get the y prime values, we have our regression equation y prime equals 4.8 plus 2.8x. We're just going to substitute our x values into our regression equation. So for our x equals 1, y prime equals 4.8 plus 2.8 times 1 is equal to 7.6. For x equals 2, y prime equals 4.8 plus 2.8 times 2 is equal to 10.4. For x equals 3, y prime equals 4.8 plus 2.8 times 3 is equal to 13.2. For x is equal to 4, y prime equals 4.8 plus 2.8 times 4 is equal to 16.0. For x equals 5, y prime equals 4.8 plus 2.8 times 5 is equal to 18.8. Hence, the values for this example are x is equal to 1, 2, 3, 4, and 5, while our y values are 10, 8, 12, 16, and 20, and our y prime values is 7.6, 10.4, 13.2, 16.0, and 18.8. Now, let us move on to step 2, which is to find the mean of y values. Y bar equals the sum of y values 10, 8, 12, 16, and 20 divided by the n, the number of y values, which is 5. 66 divided 5 is 13.2. So we have 13.2 for our y bar, or the mean of our y values. Step 3 is to find the total variation with the use of this formula, summation of y minus y bar squared. So 10 minus 13.2 squared is equal to 10.24. 8 minus 13.2 squared is 27.04. 12 minus 13.2 squared is equal to 1.44. 16 minus 13.2 squared is equal to 7.84. 20 minus 13.2 squared is equal to 46.24. We're just going to add them all to come up with our total variation. So 10.24 plus 27.04 plus 1.44 plus 7.84 plus 46.24 is equal to 92.8. So our total variation is 92.8. Step 4 is to find the explained variation with the use of formula summation of y prime minus y bar squared. So our first y prime is 7.6 minus our y bar, which is 13.2, and then squared, and that is equal to 31.36. 10.4 minus 13.2 squared is equal to 7.84. 13.2 minus 13.2 squared is just 0. 16 minus 13.2 squared is 7.84. And lastly, 18 minus 13.2 squared is equal to 31.36. Again, we're just going to add them all up to come up with our explained variation. So, 31.36 plus 7.84 plus 0 plus 7.84 plus 31.36 is equal to 78.4. And that is now our explained variation. And our step 5, which is our last step, is to find the unexplained variation with the use of the formula summation of y minus y prime squared. So, 10 minus 7.6 squared is equal to 5.76. 8 minus 10.4 squared is equal to 5.76. 12 minus 13.2 squared is equal to 1.44. 16 minus 16 squared is just 0. And lastly is 20 minus 18.8 squared is equal to 1.44. Again and again, we're just going to add them all up to get the unexplained variation. So, 5.76 plus 5.76 plus 1.44 plus 0 plus 1.44 is equal to 14.4, and that is our unexplained variation. And that is the procedure in finding the three types of variation. Notice that our total variation is equal to the sum of explained variation and unexplained variation. Coefficient of determination. What is coefficient of determination? The coefficient of determination is the ratio of the explained variation to the total variation and is denoted by r squared. That is, r squared equals explained variation divided by the total variation. From our example earlier, our explained variation is 78.4 and our total variation is 92.8. So that is r squared equals 78.4 divided by 92.8 is equal to 0.845. The term r squared is usually expressed as a percentage. So in this case, 84.5% of the total variation is explained by the regression line using the independent variable.
Coefficient of determination simply denoted as r squared. In order to find and compute the coefficient of non-determination, we need just to follow this formula: 100 minus r squared. In short, you need to find first the coefficient of determination, then use it to subtract 100 and find the coefficient of non-determination. So we've got r squared is equal to 0.145 or 84.5%. 100 minus 84.5, therefore we've got 15.5 as our coefficient of non-determination. Next step is to find the standard error of the estimate. The standard error of the estimate is the estimation of the accuracy of any predictions. It is simply denoted as. Now, let's try to solve this example. So we got the first step, to make a table as shown. Second step is to use our regression line equation y prime is equal to 55.57 plus 8.13x to find the third missing number in the third column. We just need to substitute the value of x on our equation. There are the results. Step 3. Subtract y by our y prime to find the answers for the fourth column. step 4 is to square the answer step 3 and place it in the last column and find the sum of them all. So our table has been complete. Let's move on to our last step, substituting the values in our formula. So there it is, the standard error of the estimate. Next, we'll need to find the prediction interval. A prediction interval is a range of values that is likely to contain the value of a single new observation given specified settings of the predictors. Why do we use these intervals? It is to provide a way to quantify and communicate the uncertainty in a prediction. And this is the formula in finding the prediction interval. Using the data we have in our last example, let us find the 95% prediction interval for the monthly maintenance cost of a machine that is 3 years old. Let's start having the solution. Step 1 is to find the summation of x squared, and the mean of x. Step 2. Find the y prime of x is equal to 3. Substitute based on our regression line equation. Step 3. Find the value for our standard error of the estimate. And in our last step, we have to substitute the value based on our formula. We have a given value, they sub a divided by 2 is equal to 2.776. And there it is, the result. Hence, you can be 95% confident that the interval 60.53 is lesser than y, lesser than 99.39 contains the actual value of y.